FEA Model Updating. FEA Model Updating involves changing properties of an FEA model so that its modes more closely match a set of experimental modal parameters. It is called targeted model updating because you can select modal frequencies and mode shapes to be matched, and select portions of the FEA model and FEA properties to be updating. Model updating uses the SDM method to rapidly calculate new FEA modes due to each FEA property change. A search process is used to find the 10 best solutions of FEA properties that yield FEA modes that closely match the EMA modes. This exhaustive search procedure guarantees that the 10 best solutions in the user-defined solution space will always be found. The 10 best solutions are those that minimize the absolute difference between each pair of FEA and EMA modal frequencies, and optionally maximize the MAC value between the same pair of FEA and EMA mode shapes. Any one of the 10 best solutions can be saved, and the FEA Calculate Updated Modes command can be used to calculate the new modes of the updated FEA model. This command also uses the SDM method to calculate the new mode shapes. It doesn't require the entire FEA model in order to calculate the mode shapes of the updated model. To illustrate FEA model updating, we will update the thickness of the vertical plate in the FEA model of the Jim beam structure from the frequency-based ODS demo project so that its FEA modal frequencies more closely match its EMA frequencies. The FEA modes were calculated in the previous tutorial, Experimental FEA Chapter. They are also contained in the tutorial FEA Model Updating.vt.prj file in the My Documents MEscope folder. Open the tutorial FEA Model Updating.vt.prj file from the My Documents/MEscope folder. Open the following 4 file windows from the project panel. Structure Photo Jim Beam, Structure FEA Stick Model, Shape Mode Shapes, and Shape FEA Modes. Execute Draw, Animate in the Structure Photo Jim Beam window to initiate animation. Select Shape Mode Shapes in the Animation Source list on the toolbar to display its mode shapes in animation. Execute Animate, Compare Shapes. A dialog box will open. Select Structure FEA Stick Model from the list and click on OK. The comparison display of the FEA and EMA mode shapes will begin animating. The EMA mode shapes are displayed on the left and the FEA mode shapes on the right. The two shape tables are displayed below the structure window. Click on each shape button in the Shape Mode Shapes and Shape FEA Modes windows to display the two shapes compared in animation. Notice that the first 6 FEA modes have rigid body mode shapes, and that mode 7 at 62 Hz does not match any of the EMA mode shapes. Each of the 10 EMA mode shapes does match with one of the FEA mode shapes as indicated by MAC values close to 1. Usually, an imported FEA model will have many more points than its corresponding EMA model. Also, the points will be numbered differently on the two models. However, before FEA and EMA mode shapes can be used for the FEA model updating or MAC calculations, each EMA mode shape DOF must have the same point number and direction as the FEA mode shape DOF corresponding to the nearest point on the FEA model. The process of finding and renumbering the nearest point of an FEA model to each point on an EMA model is called point matching. After the FEA and EMA models have been aligned geometrically, point matching is done by executing the FEA point matching command. When FEA point matching is executed, the following steps are carried out. 1. The nearest point on the FEA model to each point on the EMA model is found. 2. Each EMA point is renumbered using the point number of the matching FEA point. 3. Each EMA shape DOF is renumbered with the number of its corresponding renumbered EMA point. 4. The measurement axes of each EMA point are copied to each matching FEA point. And 5. Each FEA mode shape component is transformed into the measurement axis coordinates of its matching FEA point. To illustrate point matching, some of the point numbers on the FEA stick model will be changed so that they are different than the point numbers of their matching points on the EMA model. Then, point matching will be used to renumber the EMA points to match the renumbered FEA points. Execute Animate, Draw in the structure EMA Photo Gym Beam window to terminate animation. Execute Draw, Number Points in the Structure FEA Stick Model window to open the Numbered Points dialog box. Press the Clear All button in the dialog box. Click on Yes in the dialog box that opens to clear all of the point labels from the FEA Stick model. Click on the first 3 rows of points on the upper plate to number them as shown. After you have numbered some points, click on Close in the Number Points box. The FEA stick model now has some renumbered points, but the rest of the points are unnumbered. Execute FEA, Calculate, Normal Modes in the Structure FEA Stick Model window to calculate its FEA mode shapes. Click on Yes in the dialog box that opens. Enter 20 into the next dialog box that opens, and click on OK to calculate the new FEA modes. Enter New FEA Mode Shapes into the dialog box that opens next, and click on OK to open the new FEA Mode Shapes window. Execute Tools, Assign Measurement Numbers in the new FEA Mode Shapes window, and assign the new mode shapes to the FEA stick model. The mode shapes in Shape New FEA Mode Shapes will now be compared with the mode shapes in the Shape Mode Shapes shape table. Execute Draw, Animate in the Structure Photo Gym Beam window and animate the mode shapes in the Shape Mode Shapes shape table. Execute Animate, Compare Shapes, and select Structure FEA Stick Model in the dialog boxes that open. A comparison display of shapes from Shape New FEA Mode Shapes and Shape Mode Shapes will be animated. Notice that when a matching pair of mode shapes is animated, the shapes are the same, but their MAC value is very low. Prior to executing the FEA point matching command, the following steps must be carried out. 1. Create an FEA substructure and an EMA substructure from each structure model. 2. Copy or paste the 2 substructures into the same structure window. 3. Align the 2 substructures so that the points on the EMA substructure are as close as possible to the points on the FEA substructure. To create the EMA substructure, execute Edit, Objects, Points, in the Structure Photo Gym Beam window to make the points the current object type. Execute Edit, select Objects, select All to select all points on the structure model. Execute Draw, add selected objects to substructure. Press the New Substructure button in the dialog box. Enter EMA substructure into the next dialog box, and click on OK to create the EMA substructure. To create the FEA substructure, execute Edit, Objects, Points in the Structure FEA Stick Model window to select points as the current object type. Execute Edit, select Objects, select All to select all points on the FEA Stick Model. Execute Draw, add selected objects to substructure. Press the New Substructure button in the dialog box. Enter FEA Substructure into the next dialog box, and click on OK to create the FEA substructure. Next, the two substructures will be placed together in a new structure window. To copy the FEA substructure into a new window, select only the FEA substructure in the Structure FEA Stick Model window. Execute Edit, Copy Objects to File. A dialog box will open. Press the New File button and copy the substructure into a new structure window called Point Matching. To copy the EMA substructure into the same window as the FEA substructure, select only the EMA substructure in the Structure EMA Photo Gym Beam window. Execute Edit, Copy Objects to File. A dialog box will open. Select the Structure Point Matching file in the dialog box and press the Add To button to add the EMA substructure into the Structure Point Matching file. The Structure Point Matching window should now have both the EMA substructure and the FEA substructure in it. To align the two substructures, execute Draw, Drawing Assistant to open the Drawing Assistant tabs. Select only the FEA substructure. On the Position tab, press the Global button to center the FEA substructure around the global origin. Select only the EMA substructure. On the Position tab, press the Global button to center the EMA substructure around the global origin. The two substructures are aligned and are now ready for point matching. Select both the FEA substructure and EMA substructure in the Structure Point Matching window. Make sure that both the Shape New FEA Mode Shapes and the Shape Mode Shapes windows are open. Execute FEA Point Matching. A dialog box will open. Select Shape New FEA Mode Shapes in the left list and Shape Mode Shapes in the right list, and click on OK. Point matching will now proceed using the two selected substructures and the two shape tables chosen in the dialog box. When point matching is completed, a series of dialog boxes will open, asking if you want to save each of the point match substructures and shape tables into new files. Click on Yes to save each new file. Name the FEA substructure and shapes Matched FEA Structure and Matched FEA Modes in the dialog boxes that open. Name the EMA substructure and shapes Matched EMA Structure and Matched EMA Modes in the dialog boxes that open. Execute Tools, Assign Measurement Numbers in the Shape Matched FEA Modes window to assign its measurement numbers to DOFs of the structure Matched FEA Structure Model. Execute Draw, Animate in the Structure Matched FEA Structure window and verify that the mode shapes in Shape Matched FEA Modes are valid. Execute Tools, Assign Measurement Numbers in the Shape Matched EMA Modes window to assign its measurement numbers to DOFs of the structure Matched EMA Structure Model. Execute Draw, Animate in the Structure Matched EMA Structure window and verify that the mode shapes in the Shape Matched EMA Modes are valid. As a final check of the matched mode shapes, their MAC values will be displayed in a MAC bar chart. Execute Edit, select Shapes, select None in both the Shape Matched FEA Modes and Shape Matched EMA Modes windows. Execute Display, MAC in the Shape Matched FEA Modes window. A dialog box will open. Select Shape Matched EMA Modes in the dialog box and click on OK. The MAC bar chart will be displayed, showing that the mode shape pairs with renumbered DOFs still have the same MAC values. The Structure Matched FEA Structure, Shape Matched FEA Modes, and Shape Matched EMA Modes files are now ready for FEA model updating. All of the FEA stick model plate elements use the same plate property, plate 01, which is an aluminum plate with 0.375 inch thickness. Model updating will be used to change the thickness of the plate elements on the vertical plate of the FEA stick model so that its FEA modal frequencies and mode shapes more closely match its EMA frequencies and mode shapes. The first 6 modes in the Shape Matched FEA Modes file have rigid body mode shapes. We are only interested in matching the FEA modes with the available flexible body EMA mode shapes. Therefore, these 6 modes will be deleted from the FEA modal model prior to using it for model updating. To delete the first 6 modes in the Shape Matched FEA Modes file, press the Select Shape button for Mode 1, Row 1 of the Shape spreadsheet in the Shape Matched FEA Modes window. Hold down the Shift key and press the Select Shape button for Mode 6 or Row 6. Execute Edit, delete selected shapes, and click on Yes in the dialog box that opens. Recall also that there was no EMA mode with a mode shape that matched the 62 Hz FEA mode shape. Therefore, in order to pair the FEA and EMA mode shapes correctly, another mode will be added to the shape matched EMA modes file. Execute Edit, Add a Shape in the Shape Matched EMA Modes window. A new 0 Hz mode will be added to the end of the shape file. Execute Edit, Sort Shapes, Ascending. The new 0 Hz mode is now added to the beginning of the Shape Matched EMA Modes file. This will allow the higher frequency modes in the Shape Matched EMA Modes file to be correctly paired with the shapes in the Shape Matched FEA Modes file. To update the thickness of only the FEA quads on the vertical plate of the FEA stick model, the other FEA quads in the model will be hidden. This is done by selecting all FEA quads except those on the vertical plate and depressing their Hide button. Execute Edit, Objects, FEA Quads in the Structure Matched FEA Modes window to make the FEA quads the current object type. Execute Edit, Select Objects, Selection Box, and draw a selection box to enclose and select all of the FEA quads on the back plate. Execute Edit, Select Objects, Invert Selection to select all of the FEA quads on the top and bottom plates. To hide the selected FEA quads, execute FEA Objects List to open the list of all FEA objects on the matched FEA structure. Double-click on the Hide column in the spreadsheet. Select Yes in the dialog box that opens, and click on OK to hide the selected FEA quads. Close the FEA Objects List box. FEA model updating requires the correct engineering units for both the structure model and its mode shapes. Display the Units column in the DOF spreadsheet in both the Shape Matched FEA Modes and Shape Matched EMA Modes windows to verify that the shape units inches per pound force second. These are typical units for unit modal mass mode shapes. To check the units in the matched FEA structure, execute File, Options in the Structure Matched FEA Structure window to open the Options dialog box. On the Units tab, select the English units and click on OK to close the window. The FEA model is now ready for FEA model updating. To perform updating on the thickness of the FEA elements for the vertical plate of the GenBeam FEA model, execute FEA Model Updating in the Matched FEA Structure window. A dialog box will open. Select Shape Matched FEA Modes in the FEA Shapes box and Shape Matched EMA Modes in the EMA Shape box, and click on OK to open the FEA Model Updating window. The FEA and EMA modal frequencies are listed in the upper spreadsheet together with the MAC value for each FEA and EMA mode shape pair. The MAC values indicate that all of the mode shape pairs are similar. However, all of the FEA modal frequencies are all less than the EMA frequencies, so we would expect the updated thickness of the vertical plate to be increased in order to raise the frequencies of the FEA modes. The mode shape pairs to be used in the calculation of the error function are chosen by selecting them in the first column of the upper spreadsheet. If none are selected, then all of the pairs will be used. Select 5 modes to include these modes in the error function calculation. Depress the Include MAC buttons for the same 5 modes to include their mode shape MAC values in the error function calculation. The lower spreadsheet is used to define the solution space over which solutions will be evaluated to find the 10 best solutions. In order to stiffen the FEA model so that its modal frequencies more closely match the EMA frequencies, we would expect model updating to find a larger thickness than the current value of 0.375 inches for plate 1 as shown in the lower spreadsheet. The solution space for plate 1 will be defined to evaluate its thickness using 100 steps between property minimum equals 0.30 and property maximum equals 0.60. Depress the Select Property button for plate 1 to select this property for updating. Enter 0.30 for the minimum property for plate 1. Enter 0.60 for the maximum property for plate 1. Enter 100 property steps for plate 1. The model updating window is now ready for calculating the 10 best solutions. Press the Calculate Solutions button. The error box in the model updating window displays the current minimum error as the 100 solutions are being evaluated. When this number stops decreasing, the best solution may have already been found. When all 100 solutions have been evaluated, the Stop button will no longer be displayed, and solution 1 of the 10 best solutions will be displayed. Each of solutions 1 through 10 is displayed on the lower spreadsheet by clicking on its tab. As you click on each tab, the solution value is displayed in the Updated Value column in the lower spreadsheet, and the updated modal frequencies and MAC values are displayed in the upper spreadsheet. Press the Plot Solutions button to display an interactive 3D bar chart of all the 10 best solutions. Hold down the right mouse button and drag to rotate the 3D bar chart. Place the mouse pointer on one of the solution bars to display its value. This is the expected result. All of the 10 best solutions include a plate thickness greater than the current thickness of 0.375 inches. Solution 1 has the smallest error value, meaning that a thickness of 0.4303 inches yields FEA modal frequencies and mode shapes that are the best match with the EMA frequencies and mode shapes for the first 5 selected modes. Any of the 10 best solutions can be used to update the FEA model and calculate its new mode shapes. Close the Solution 3D bar chart. Click on the Solution 1 tab to display its solution in the Updated Value column. Press the Save Updated Values button. Execute Edit, select Shapes, select None in the Shape Match FEA Modes window to unselect all of the mode shapes. Execute FEA, Calculate Updated Modes. In the dialog box that opens, select Shape, Match FEA Modes, and click on OK. Save the updated mode shapes in a new Shape Updated Modes file. The mode shapes of the Shape Updated Modes file should have the same frequencies as the updated frequencies listed for Solution 1.